Good morning. How's everybody doing today? Hope you're having a great day. Oh, this goes over here. Happy Wednesday. Right now my computer's gonna be slow. Come on. Let's go. You're fine. All right. We've got more to talk about for classes here today. And any last minute questions for project 3? That one's coming up due on Monday. Right? Monday, 10 a.m., project 3. So any other questions on that one? Weird morning. I'm in Coke Zero instead of coffee right now. Did not get a chance to make my pot of coffee. I'm sad. But that's okay. That happens sometimes. All right. Hey, Dusty. Yep. Regular class today. Don't forget, we've got the tutoring session right after class at noon here. Bring your questions. Chat about projects, about course content. Get to know each other a little better. Hang out on Zoom. Don't forget the final project. If you're interested, you can do it in pairs. It's not required. Usually I like people to work in pairs, but given all this remote learning stuff, I don't think that'll go quite as well as when we're actually in class in person and we've got time like sitting next to each other to work on stuff. So it's optional if you want to work in pairs for our final project that's upcoming. Well, that's a great chance to get to know each other. And if you attend, you can get 1 extra bonus point every week towards your quiz scores. We'll talk about classes. Finish that up. I'll post the quiz for classes. I'll make a note for myself here. Post chapter 6 quiz. There we go. Don't want to forget that. And then we're moving on. We only have a couple more chapters to work on. Some miscellaneous topics this last week. And then April 26th and 28th, I have reserved just to work on the final project. Again, usually we're in person in class and we can meet with our partners and whatever, but we'll have that time reserved for you to work on the final project. I can answer questions, whatever you folks might be stuck on. And then we've got one last individual project as well coming up. We'll talk about that one next week. And then that final project. So definitely take advantage of those group tutoring sessions right after lecture. We'll meet at noon and we can go from there. All right, let me fire up NetBeans here. All right, and while that loads, I want to give you a cautionary tale of children's songs. My little guy is real big into all those earworm style kid songs that once you hear it, you just can't get it out of your head. If you do !book, I think I've got our book there that we're using for this course. Hey, good morning, another random guy. There's also a decent free one if you'd rather have a free book. It is David Eck Java book. I think it's Eck. I think that's right. Yeah, I think that one's it. It is This one, maybe. No. Let's see. Yeah, this one here. Java Notes. This is what I'm thinking of. His book is covers a lot of material, and it's totally free because this guy is pretty awesome. So if you're curious, there's also that one. If you want to avoid Pearson and their higher ed monopoly and nonsense. Not that the book isn't good. Mr. Gaddis didn't do a good job or anything, but they just overcharge. Yeah, they cover most of what we get into as well. He only has a little bit of GUI programming work here. So we'll go a little bit different into what we do in ours. But this is pretty close, actually, using JavaFX. So, like, yeah, he did a nice job of this. It's all linked out, man. All right, cool. Oh yeah, so anyway, so my kid has been all about all of those songs that get stuck in your ears. So I had this problem where I was just, the Hokey Pokey song was stuck in my head, and it was like all I could think about, and like that's all he wanted to do was the Hokey Pokey song, and I feel like he was kind of getting addicted to the song. Like for some reason that was just so, like, that's the only thing he wanted to do, and he'd be grumpy if we weren't singing the song. So I mean, he was a real Hokey Pokey addict, but thankfully he was able to turn himself around. All right, let's open up chapter 6 here. We were killing Pearson with used textbooks. Oh, man. Yeah, that's... Oh. That's why they come out with a new edition every, couple of years. Sure, I get it. Java itself does come out with new editions, right? And there's new things in the Java language that is nice, would be nice to put in a book. I get that. Sure. But, like, math textbooks? Really? Well, hang on. Which one is this? I currently have the 6th edition of a calculus textbook on my desk. That is actually the riser for my second monitor to give it, a couple inches up so it can be above the laptop monitor. And I believe there's a 7th edition of that one now. I don't think calculus has changed much. No. I don't know what changes between the editions. I'm not really sure. Biology, we've learned a little bit more here and there, but like an intro to biology textbook probably doesn't need 11 editions over the last, 20 years, but maybe it does. Yeah. Number on the cover. And then how much they charge for it, right? Which is unfortunate. I mean, it's fair that authors put in a lot of time, energy, and effort to make these textbooks. That's true. They do. But, okay. I actually have a buddy, one of my faculty friends over at Dearborn. He's a co-author on a book. And that's a really good book. And I've seen the amount of time he puts into that, and when they do revisions and updates and things. But again, it's a software book, so like things have changed in software. So now you're trying to make me remember this here. Practitioner approach, is that right? think this is it. Is it Pressman? It's on a Google Drive file? Huh. Don't click random Google Drive links, just FYI, friends. Is a PDF for it? Really? Wow. That's interesting. That's probably why. I think those are the older ones. Let's see. There's a newer one out there too. I don't remember. Let's see if this one's it. Yeah, if you do exclam YouTube, I've got a link to my YouTube channel there, random guy. Yeah, this one. Oh yeah, and Dr. Maxim. Is this the latest edition? 9th. And this is the International Student Edition for use outside the United States. So this one is cheaper than the one for students in the United States. Who knew, right? Oh yeah, right here, $229 for this one here, for the non-international edition. $40 for the international edition. Let's see, is this? Oh, this is the 8th edition. Okay. Where's the 9th edition? I don't know. I should be able to find stuff better on Amazon, but sometimes it doesn't. I just click Maxim here. Let's see. Dr. Maxim's a nice guy. Real nice guy. Let's see, does he have the 9th? I don't see it. It's not linked here. Huh. Okay. Anyway, what are we talking about? Textbooks, right? Let's come back here to Chapter 6. So again, thinking about classes and designing classes when we're writing solutions. It's a big shift in how we've done things so far. And that's okay. Right? What we're doing is we're adding this tool to our toolkit of ways that we can solve problems. And honestly, I think that the biggest reason classes are useful is that it's a more natural approach compared to what we're used to, as humans, thinking about things. So, like, I've got a bottle here, right? When I just tell you a bottle, you can think of all sorts of different kinds of bottles, right? These are bottles. These are bottles. My little guy still drinks milk bottles from baby bottles. So you don't really know specifically which kind of bottle it is, but you have a general idea of what a bottle is, right? It's a container. It can hold some liquid. Usually it has a top, that sort of thing. But then I can start giving you details of individual bottles. Like, hey, this one is clear. It has a black top. It holds 12 ounces. Is it 12 ounces? Holds 12 ounces. These sorts of details. It has that unique Coke bottle shape that I believe they patented or trademarked or something. Probably a trademark, right? So each actual bottle, or you might say an instance of a bottle, or each object then has its own set of attributes that describe and make that bottle different than the other bottles. Okay? And we do the same thing with code, right? We define the generic type here as our class, so like rectangle. And this is kind of boring. We'll do some other examples in a minute. And then they have the list of attributes, all the things that make rectangle specific, a actual instance of rectangle or an object. So in our case, we have length and we have width, and then we talked about calculating area or not calculating or saving it. Either one's perfectly fine. So it just depends on how often we're going to use it, that sort of thing. And that's sort of one of the judgment calls. So as long as it gets the job done, it's okay. All right, so we have rectangle. This is a constructor that will create rectangle. Remember, when we create objects, we say, hey, I want a rectangle here. We say equals new rectangle. So here's my type. Here's my variable name. We're assigning it a new rectangle. Java will go out and create this object in memory for you. We've done this before with scanner, right? We would say scanner keyboard or something equals a new scanner given system.in, right? Scanner is the type, keyboard's a variable name, equals a new scanner, creates the object in memory. Excuse me. Yeah, and it doesn't, we haven't used scanner here, so we didn't do our imports yet. That's fine. Okay. We've done that before. We're making these objects in memory, and they're storing that information. So I think we looked, scanner can be used to read files, or it can be used to get input off the console. You can do a lot of cool things with scanner, where we've only done some of them. Okay. For bank accounts, right, it has some private attributes, and it has public methods. And that's kind of the format we're going to follow. One of the principles of object-oriented programming is encapsulation and abstraction. They're kind of go hand in hand is how I usually consider them. The idea with encapsulation is we've taken all of the details about a noun or our class. Typically they're nouns. They're not always nouns, but in general your classes will be more nounish than other things. So all the attributes about that class become its private instance variables. Right, so these belong to each instance of bank account will have its own string for name and its own double for balance in memory. So if I make 50 bank accounts, I'll have 50 different balances and 50 different names in memory. Right, so we're encapsulating all of the details. So all the things about my class get hidden away as private values. Right, we want to make one nice, neat little package. And then what we do is we give public methods like deposit or withdraw or get balance or get name. We give public methods that allow you to interact with the class. Now that's part of this abstraction piece. The idea is that you don't actually need to know the details of bank account. You just need to know, here's a bunch of public methods that you can use, and they will do things with the class. Right? We can deposit, we can withdraw, and we can get some values back out. So what we're dealing with, we would consider this when someone is using bank account, they're dealing with the abstract part of it, because they don't know exactly what bank account does. They just know, hey, here's a class and here's a bunch of methods. Just like we did with scanner, right? We said, oh, sure, hey, we don't know how scanner does next line, but we know there's a method called next line, and it will give me the line that they've typed in at the console. Okay? And then we looked at testing. Right? And tests are amazing because the computer is much better at this than we are. Okay? So to get to it, or to generate new ones, right? You come to your class, you right-click on it, you say navigate, go to test. We already have some here. Great. So it takes us right to the file. If we didn't have tests, like I don't think we had rectangle tests, right? Right-click, navigate, go to test, and it says, oh, do you want to make some? Make sure you pick JUnit 4. Again, regular JUnit probably could work if we spent a lot more time on it, but for some reason it doesn't work right away. So just pick JUnit 4. It makes life a lot easier. It's the same idea. Okay? The JUnit 4. You don't need to check any of these other boxes. It gives you a lot of other stuff that is not always as helpful as you might want. And you say OK, and it goes and makes a file for you. It's generating my tests. Hang on, it's taking just a second. There it goes. Okay? And then what we do is the idea with these are unit tests. We want to test one small unit at a time, typically one method at a time. And we want to test all of the different cases that we have. So in rectangle, right, we are checking to make sure that we give it valid lengths. Okay, so there's an idea when we talk about testing, one of the things we want to do is we want to get every line of code in our class that we're testing to run. We want to get 100% code coverage of our class that's being tested, right? Because that way we have a better feeling for, yeah, it probably doesn't have bugs. Now, there's no guarantee, right? Just because we have tests and just because we got to 100% code coverage doesn't mean we didn't screw something up. It just makes it harder for us to screw it up. right? So that you're less likely to have bugs with better unit testing. But to get to 100% code coverage, right, we need to make sure that all of these lines of code will run. So if you have an if with an else, you need to make sure you're testing the if, you need to make sure you're testing the else. In our case, we don't. So it's not going to be too hard. We just have to give it a regular length. But we probably also want to give it a negative length and make sure it doesn't change, right? Like we do with bank account tests. We said, hey, if I deposit negative, it shouldn't do anything. If I tell it to give it negative $100, nothing should change. So what we do is we use this AAA convention. We arrange all of our variables. So we have everything with a nice name ready to go. Okay, we've arranged everything. Then we actually act. We call the code that we're testing, right? Let's use the code. This is what I'm unit testing. I'm testing deposit here. Some people put the constructor up in a range. That's fine too. One way or the other, I'm not too particular about it. But the idea, you want this to be the code that we're testing. So we're testing, okay, we'll make an account with an initial balance. We'll try and deposit negative money. And then we'll check what the balance, what our class thinks its balance is. And that's our actual balance. So we say, I expect to have 100. The class actually thinks it has this. And then we assert. So we arrange, we act, and we assert. So the assert says, make Java check, do these things match? Oh, hydration. Thanks so much, Fallen. These 12-ounce bottles are kind of ridiculous. I gotta be honest. Nothing like a pot of coffee, which is much better. Pots of coffee are much superior, right? Okay, so and this assert equals, when we're comparing doubles, remember Java is bad at math. I tried to prove it to you and I just failed horribly at that. And it's usually much worse at math, but that's okay. You have to say, how close is close enough? So in our case, sure, just throw a bunch of decimal places in there, and that'll be close enough. It's probably pretty good at giving us 100 here, but we just wanted to be sure, and otherwise it yells at you if you don't have the delta. Okay, so we tested depositing, and we tested this one with the string version of it, right? If we deposit a string value, because we're going to make our code nice and friendly. Okay. So we've tested, and we had 100% code coverage. Again, there's tools you can get. Most of them you have to pay for, best I can tell, that'll measure that sort of thing automatically for you. All right. We talked about UML diagrams, which are fantastic, right? Anytime you can spend designing your solution, you're better off for it, right? Because then you've thought through what this thing should look like. We talked about pseudocode a little bit, just kind of get down our ideas in English, use like an Englishy version of what's supposed to happen. UML, it's not all that Englishy, but it lets us, make a picture of what our class is going to look like here. Okay, so the constructors, rectangles. We talked a little bit about if you don't have a constructor defined, then Java gives one to you. So the no argument constructor that takes no arguments, Java will write one for you. And it just sets all your numeric values to 0. It sets reference types to null, which can cause all sorts of problems down the road. We're not quite there yet. Booleans to false. So usually it's better to write your own so you know explicitly what you're getting, right? Or you write one that takes parameters, a parameterized constructor, right? You tell me the length and width of this rectangle when you make the object. I'm a fan of those, right? So this way we can say, hey, I want it to be 10 and 5, then I don't have to call set here's, right? I don't have to spend any time doing all those sets. Let's see, string class, yep. Okay. So here's a fun one. So what we could do, we did this print rectangle method, right? You can pass a rectangle to a method. Right? So as we think about writing methods here, right, we can pass instances of objects. I can say, hey, you need to give me a type of rectangle. Excuse me. We talked a little bit when we pass things to methods last chapter. Things like primitive types are integers, are doubles, are characters, not strings, but characters, booleans, floats, all those those primitive types, they get passed by value, which means you're getting a copy of it. You're not getting the original value, so you can't change it. Does that ring a bell? Right? Because we're passing a copy of it, we're not able to change it. When you pass objects, what's happening is, so you might technically say we're passing it by value, but it's not a copy. What we're doing is we're passing the value of your variable. So if I were to print rectangle, the value of large rectangle here, when you make an object in memory, your variable here is the memory address. What it's storing, the value of what it's storing is where that lives in memory. Right? And I think we looked at, I could just print large rectangle here. So when I run this one here, if I print it now, I'm going to get some gibberish looking thing. That's okay. Come on. Let's go, NetBeans. Sorry. Drink. So here's this value. It's a rectangle, chapter 6.rectangle at some hexadecimal at location. This is its memory address, essentially. Right? And this is the package. Right? The package is just our folder. Rectangle is the class name. Right? It's a type of rectangle in the chapter 6 package. Okay? At this memory location. So that's technically, this is essentially the value of that variable. So when I pass it to print rectangle, I have this, right? And if I print it again, if I were to print out that rectangle, you're going to see that same memory address, right? Because we didn't make a new rectangle. That's the idea. So when we pass primitive types, when I pass integers, we're actually giving them a copy. We're making a new integer in memory and handing it to them. We're not saying, oh, hey, my integer value is over here at memory, at this memory address, so we can't change it. That's right, Alexa Brat. Coffee time, but sadly I'm on to Coke Zero. Here we go. Right, so we've passed the value of the variable, which is its memory address. So essentially what happens there is we're saying it's passed by reference. We say, here's a reference to this object in memory. That's what we call these. So reference types, right? Anything that's not a primitive type, anything that deals with classes, those are reference types because they reference an object in memory. We say, hey, this is where it lives, over here. So when we pass something as an object, we're passing its reference. And what that means is inside of here, I can say rectangle dot, and any method that it has, I can call. If I want to, I could go set length and set width. Right? We could set that to 100. Because we have the reference to this object in memory, and we can call its public methods. Okay? So when we do that, we just need to be a little bit careful and know that they can call the methods on it. Okay? Not too big of a deal, but just something to be aware of. We'll get more into that next semester if you want to continue on and take 2151. We'll talk more about that. We had constructor overloading. We did bank account. We did, I think shadowing's perfectly fine. I don't care. Mr. Gaddis does not recommend that you have an argument called name, because then your this name is shadowed. Right? I say it's easy enough to find the purple one, right? The instance value at this dot, because then you have better argument names, right? Do not do string n for name. Please don't do that, right? Give a nice, meaningful name, like all of our variables. They should be nice and meaningful, okay? So I disagree with Mr. Gaddis there. So when we're designing our solutions, right, we're going to look at, okay, what are the problems? Uh-oh. We having network issues? Sorry. Okay. Sorry, folks. Man, you just missed the whole talk about defining classes. That's okay. So typically our classes are nouns, not always the case, right? Any attribute of the noun, anything we use to describe that noun, could be private instance variables here, right? And then ways that we interact with it, right, are its public methods. So it's kind of the way that we go about solving problems. Okay, so let's write another class here. Let's do let's do bottle, right? We were talking about bottle. Why not write bottle? Okay. So some attributes of bottle, right? Private, we'll go integer. We'll go max volume. And when you're dealing with attributes, it's really nice to give them units. So we could say ounces, or we could say milliliters. Milliliters. I'm going to go with milliliters because the metric system is much superior, and we really should be using that everywhere. We have a max volume, so that's the total volume size, and then I might have an int current volume in milliliters. Right, milliliters is the worst because I can never spell it right, but that's okay. Now we might have a string for name. Sure. We might have a string for color. Okay, that's probably good for now, right? We don't need a ton. So these are different attributes of bottle. Right? And then we can make a constructor. So public bottle. However, constructors don't have the return type, and their name matches the class name. So what do we want people to give us? Well, probably the name, probably the color, and I don't know, why not the max volume? Now, I'm going to say let's not have an argument here for current volume, right? And we'll assume we're empty. So my this name is the name, my this color is the color, my this max volume is the max volume. I'm just copy pasting that. I was not typing that one super fast. And then my current volume, we'll just start off at 0. Right? The constructor's job is to set values for all of its attributes. Okay? That's the constructor's job. We're setting values for all the attributes. Now, things we can do with bottle. Right? How about void here? We'll have a fill. Right? So if we want to fill the bottle, let's go for it. And maybe let's have them give us a number of milliliters. Milliliters to add. Right? So when you go fill up a bottle, you tell me how many milliliters we're going to put in there. So what I'm going to do then, I'm going to take my current volume of milliliters, I'm going to increase it by the milliliters to add. Right? You tell me you want to add 200 milliliters, I'll add 200 milliliters to this bottle. It holds 355 in this Coke Zero instance. Okay, I can do that. But then we have a problem, right? Remember, one of the ideas here with object-oriented programming is that when I've encapsulated all my details away, and I'm a nice little self-contained package, my class is responsible for maintaining its integrity. And what's going to happen if someone says, hey, add 1,000 milliliters to a bottle whose max is 355? Am I going to end up with more than 355 milliliters inside the bottle? No, that's a big no, right? So we can't do that. So what we need to do then is we need to make sure our object is in a good, valid state, right? We're responsible for maintaining our own integrity. So we're going to check. We can say, hey, now, if my current is greater than the max, well, let's just set current equal to max, right? If you overfilled this thing, right, if you put too many milliliters in, a bunch of it spilled out. Sure. Well, I'm going to make sure my current doesn't go above max, because that's my rule here for a bottle. We're saying you can't do that. we're going to obey some of the laws of physics. We're a little bit particular about which ones we want to obey. But in this case, we'll obey that law of physics, right? You can't put more than the max in. Cool, that's fill. And how about drink? Int milliliters to drink. Okay, if you want to go drink from the bottle, we get the same thing, right? We're going to take our current volume minus the milliliters. So if I want to drink 100 milliliters, great. Chug, 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 chug. Excuse me. Now, but what happens though if we went below 0? Right? Can you drink milliliters that aren't there? No, my bottle's empty right now. I cannot drink any milliliters of Coke Zero, and I'm sad about that. All right, so let's check. Let's see then here if my current volume in milliliters is less than 0. Let's go put it back. Okay, now again, this isn't all that ideal. I just did a quick format there. It's not all that ideal. There's ways to handle this here. What you're going to be tempted to do, and I'm going to tell you don't do it, is put a bunch of system.out.println messages here and say, you drank too much. Wah! Don't do this, right? A good general rule of thumb, and it's not always the case, but just a general rule of thumb is that your class should never, ever, ever, ever printline. Don't do it. Okay? That is not the right way for your class to communicate. Right? Your Java class's job is to represent its object. Okay? Now, one of the ideas with object-oriented programming is that classes should be reusable. Right? We did such a nice job. We wrote this amazing class for bottle that maybe I'm going to use it in another program. Maybe I'm going to use it in a web application, and I'll let you order bottles online. I don't know, or what, something, right? But I could use it in a web application or use it in a mobile application. Right? It doesn't have to be this console-based where I've got text spitting out of my screen. Maybe I use bottle in a graphical user interface program where there's buttons to click on and things. You know what happens to system.out.println messages if you're running a graphical program or a mobile application or a web application? Nobody sees them. They go nowhere. No one's looking at the standard output, system.out. No one's looking there. They're never going to see those messages. So it is inappropriate to put messages there. We'll talk about the right way to do that another time. Okay? Probably in our miscellaneous chapters week. The right way to do that, just if you want to put it in your back pocket, is something called exceptions. Exceptions is a whole other topic that we just can't, we don't really have time for right now. We'll talk about it a little bit at the end of the semester. We'll talk about exceptions. But do not put system.out.println messages in your class. Right? Unless, the one unless there is that if that class was designed specifically to work with the console input and output, then sure, go for it. Because that's the only place you're going to use it here, right? But all the other system.out.println stuff should happen in main here. Because if you're running your program and you're running your main method here, we're probably expecting your console input and output. Okay? That's a rule of thumb. So don't put messages in your class. Okay? So we've got some public ways of interacting with our class. We also need ways to get these values back out, right? These are private attributes. No one has access. We need to write a bunch of get methods. We'll have a public int get, and I'm just going to copy paste these ones here. Get max volume in milliliters, and all that needs to do is return the max volume in milliliters. We'll have a public int for get current volume in milliliters. Get current volume in milliliters, and that returns the current volume in milliliters. We'll have a public string for get name that returns the name, and we'll have a public string for color that returns the color, and then we'll give that a little format. Clean that up a little bit there. There we go. Okay. So we got our ways of getting these values back out, right? If if someone needs to know what the value is, like how do I know what my current volume is? Great. I need a way to expose that as a public method. Okay. Then we can go write some tests. Okay, so I'm going to right click on bottle and say navigate, go to test. JUnit 4, nothing else is checked over here on the right. We should be good to go. All right, and then all of these app test methods here. So I'm going to test fill, and I'm also going to test fill over max, right? To make sure it does or doesn't go over max, right? Drink, and then drink, I don't know what, below 0, or something like that, right? And then again, these get methods, we're going to be using these gets inside the other tests here. So I'm not too concerned about having specific tests for those ones there. Name and color, we could test because we're not using name and color when we do our testing, filling, and drinking. So sure, maybe we could leave those ones. Not too big of a deal. We're going to test fill. So we're going to arrange, and then we're going to act, and then we're going to assert. Okay, so I'm going to have an int for expected current volume in milliliters. Milliliters. Right, and I don't know, so we'll say this was 355, right? That was a nice full bottle here. Okay, so I'm going to make a bottle. So my type of bottle, this is my Coke Zero Mini, right? Equals a new bottle. And I have to give it a name. Sure, Coke Zero. The bottle color itself is actually clear, right? My max volume then is the expected current volume. Sure, I like it. Okay, and then we need to fill it. So my Coke Zero Mini dot fill given the expected current volume in milliliters. Let's fill it 355. And then we'll have a integer actual current volume in milliliters. Milliliters is my Coke Zero Mini. Nope. That's all wrong. Sorry. Coke Zero Mini. There we go. Dot get current volume in milliliters. Cool. You know what we could even do here, and this will use that other method here. Let's ask our Coke Zero dot get max volume. There we go. So we'll ask for the max and say fill it to the max. I like that. Okay, and then we're going to assert. Assert equal our expected current volume and our actual current volume. Okay, and now, so typically with the unit tests, we're testing one particular method. Again, these get methods are not super interesting at all. I don't feel bad about using them in other methods because it's just get me a value back out. There's nothing that should be happening inside of a get method other than just returning. So I don't feel bad using those ones in there. So technically we've tested the get max volume and fill and get current volume. But again, you know, the get methods typically don't count. Okay? So we'll do this again. And we're going to fill over max. So let's take that max volume, I don't know, like times 2. And make sure we still have 355. Okay? For drinking. If we don't fill it, there's nothing to drink. Right? So I'm gonna set up one other variable here. I'm gonna have a max volume. Volume in milliliters. We'll go 355, and let's say we expect to have 255 when we're done. So if we fill it to max, right, and then we drink some. Coke Zero Mini.drink. If we drink, right? Well, how much do we want to drink? Let's drink 100, or maybe we'll have a variable here, right? So an int milliliters to drink is 100. Again, having nice names for everything just makes this a little bit cleaner here. And we'll see how much is actually left. We'll compare our expected current to the actual current. So if we fill it up to the max, we drink 100, we should have 255 left. Okay? And if I try and drink more than the max here. So if I'm going to expect to have 0 left if I try and drink everything. If we drink, say, like 1,000, we'll fill it up to the max. We'll try and drink 1,000, and we should have 0 left. Okay, so now we're going to run our tests. See what we get. All right, they're passing. Looking good. Okay, so we're feeling pretty good that our methods did what they were supposed to do. And it's easy to screw these up. That's why we write tests, right? It's definitely easy to mess these things up, right? And typos happen. Just like when you write an English paper, right? You know what you're trying to do, so sometimes you do the wrong thing, but your brain says, oh yeah, that looks right. No problem there. Perfect, this is exactly what I meant. And you miss all those typos. So unit testing gives us that chance to check it and say, okay, is it doing what I think it's supposed to be doing here? And really, it's the same thing we did when we would put a bunch of stuff in main. And we would make bottles, we would call drink, we would look at the volumes, but it takes the human aspect out of us having to look at the output and say, oh yeah, that output looks right. Because we've codified all of it. We said, oh, hey, go, does it actually match this? Okay, so this is that AAA format, which I'm a big fan of. Excuse me. Okay, how you folks feeling so far about classes? Let me throw out a poll here. Let's see. About classes. Makes sense. So like you can tell it doesn't make sense, is a little fuzzy, or you have no idea. So there's a little poll there in Twitch chat, and then she should be able to answer. We'll see how everybody feels about it. Okay, so take a second, answer that for me. Just give me a feel for how everyone's doing on this topic. About as deep as we're going to get. Again, we come back in the next semester if you take 2151. And we hit classes much more detailed. So we're going to practice it a lot more. Our next project will be about classes that we're going to work on. We're going to work on writing classes and writing tests for our classes. Okay? It's a lot of fun. Okay, so a little fuzzy. Yeah, it's definitely going to take some practice, right? Just watching me do it is not going to be enough there. Like anything else, practice will make things better. So we'll have a project to do about them. Right, that makes sense. Cool. All right, a couple little fuzzies. Thanks for answering that. Okay. So why don't we do this? Why don't we take our break just a couple minutes early? It's getting close to 11, and then we'll come back and we'll do some more class examples. We'll try and tackle one that's a little bit more interesting. Okay? That sound like a good plan? All right, let's do that. Let me throw some music back on here for you. And we'll come back in about 10 minutes or so. All right, awesome. We'll go to the break time screen here. Let's say what, 11:02? And we'll come back, okay? I'll see you in a couple minutes, folks. Go get yourself some coffee. Alrighty, welcome back. Oh, sorry, I overshot that a little bit. I ended up getting some leftover pizza. That's pretty exciting. Alright, so we're going to talk more about classes here. A couple other examples. Okay, and then we'll be on our way. We can finish up Project 3, and then don't forget study group today at noon. I definitely want to encourage you folks to take advantage of that. That's super cool. We've got that chance to do the study group thing. Okay? So let's see. Let's make another class here. And let's see. Let's make... What do we want to do? You know what? Let's... we've got rectangle. I got an idea here. Let's try this. This will be it's not mathematical at all. We're just going to have some fun. We're going to say, let's see, can we take one rectangle and add another rectangle to it? We'll make a method that will return a type of rectangle. And we're going to call it add together. Given a rectangle, other rectangle. So if you give this rectangle another rectangle, or another rectangle, we should be able to give you a rectangle back. So we're just gonna, we'll just add the lengths together, we'll add the widths together. So I need to make a new rectangle. So this is the rectangle, new rectangle is a new rectangle. And what do I want to do? I want to call its length and width. Well, it should be length plus, because if I'm going to add our lengths together, it's the other dot length, right? If I have another rectangle here, I can get at its private instance values, or I could call get length. Either one is fine. I could use its instance attribute directly, or I could go and use the get length public method. Both are perfectly fine. And then we'll do width. We'll do our width plus the other width here. Okay, so that will create a new rectangle. So it doesn't change my length. It doesn't change the other's length. It doesn't change my width. It doesn't change the other's width. But it makes a new rectangle in memory, given those details, and we're going to return that new rectangle. Or you might do it all in one line. You could just say return new rectangle here as well. If we want to, we could just say return new rectangle. We could just do that. Okay, so to add two rectangles together, we'll just add the lengths and add the widths and make a new rectangle and give that one back. So we'll come back to our chapter 6 here. We've got a small rectangle, we've got a large rectangle. We'll have a rectangle of weird math rectangle equals, and now because that's a method, right? That's a method in rectangle. I need to take one of my instances of rectangle. I can do either large or small. And say like large rectangle dot add together, and then I have to pass it another rectangle. I could add it with itself, or I could add it with the small. I'm going to add it with the small one. So I'll say, okay, large rectangle add together with the small rectangle. Now we have our weird math rectangle, and then let's print the details. Right, we'll call print rectangle given our weird math rectangle. I don't think you can actually add them together like that. I feel like that's bad geometry, but again, I'm not much of a math person. We'll pretend like it works like this. Okay, so our, that's right. We should probably not do this set length thing. Sorry, inside of print. And you can see you can call methods here. So let me fix that there. There we go. That's looking happier. Okay, so our first rectangle then, our small rectangle, is length of 10, width of 5, area of 50. Sure. Our next rectangle, length of 20, width of 50, area of 100. Okay, so if we add those together, like length of 10 and length of 20 should give me a length of 30, width of 5 and a width of 50, should give me 55, and a big area. Okay, seems like it's working so far. So do you see when we ask for an argument, it can be of our type of class, so then we have another rectangle, right? We could have a method like public let's do, we'll say a Boolean method here, right? We'll say is bigger than a rectangle, other rectangle. So we're going to return a true or false if we're bigger or not than this other rectangle. And for our case, we could define bigger as anything we want, but I think area is probably a good proxy for bigger. So we're going to return our area is greater than other.area. Right? If this is true, we return true. If this is not true, we return false. So please don't do this. Please don't say if area greater than other.area, return true, else return false. Please don't do this, okay? Right? Because this right here already is true or false. Okay? You don't need to say if it's true, return true, else return false. You can just say, hey, return this thing that is either true or false. Right? I see this all the time. So don't do that. Okay, just return. Hey, here's our method. We could also check then, how about is smaller than? So is my area less than theirs? How about a is same size? I don't know if same size. Do we want to compare that on area, or do we want to compare length and width for same size? We could figure it out either way. I don't know. Same size feels like you're doing length and width rather than bigger and smaller. I think area is probably fine for that, because you might have a 50 wide by 1 unit, which only has an area of 50, and you might have a 10 by 10, which has an area of 100. And the bigger area is probably bigger. So I don't know about same size. I don't know. Well, let's do this. We'll return length equals other.length, and width equals other.width. So this statement here, area is greater than the other area, is either true or false automatically. Right? If our area is greater, we return true. If our area is not greater, we return false. Because this expression here, saying area greater than other area, already is a Boolean expression. That already is a true or a false statement. So we're just going to return that true or false statement. Oh, that's a good question. Yeah, so it's faster to do this, because otherwise we're comparing if this is true, return true, otherwise return false. This is the way to do it much more efficiently, because all good programmers are lazy, right? And we're not going to write 6 lines of code if we can write 1 line, in general, as long as it's readable. As long as it's readable. Okay? So we can check, is it the same size? Sure. And now what we should do, right, is we should write some more unit tests, because we no longer have 100% code coverage. So let's go to a rectangle test. Oh, we never wrote any rectangle tests. That's okay. Let's go back. We'll write a couple ones. We're not going to do all of them. Okay. Navigate, go to test. There we go. You know what? I don't even want to test these gets in, because we're going to do all those later. That's fine. We're going to have test. I lost it. Come on. Disconnect. Connect. Hey. How about now? Are we back? Oh, I came back just as I was disconnecting my network. That's nice. You back? Meowdy. Alrighty. How about that? Sorry about that, folks. To be fair, when my network blips, Zoom would suck just as much. I do feel a little bad, but at least you'd be able to talk to each other, I guess, then? I don't know. Alright, so, where'd we leave off? Writing a test? Did we get that far? Trying to make some rectangles for tests, or did I break up before that? We finished writing the methods, right? We got it as far as writing the methods. Bigger than, less than, same size. Okay, cool, at the tests, cool. So we're gonna make two rectangles, a small rectangle and a big rectangle. Rectangle, say, I don't know, 5 by 5. Okay. And then we have, and so now this one here with a true or false value actually works out really nice. We don't need to say, here's the expected result, because what we assert is either true or false. So we're going to have a Boolean for actual is bigger than is the large rectangle dot is bigger than the small rectangle. Okay, and then we can assert, we'll say assert true here. Actual bigger than is bigger than. So I don't need to compare like is true equal to true, because of the assert, I don't need to use an assert equals true equal true. I can say, hey, assert true. So that skips that one step of having, here's my expected result, because it just gets coded right in here as the assert. Excuse me. And then we'll have it is smaller than. Is smaller than. And you know what, we could actually do both of these. Than, is that right? Smaller than? T-H-A-N, is that a word? Than the other one? Smaller than the other one? Maybe it is. You know, I'm gonna do another one here. I'm gonna Boolean actual is smaller than is the large rectangle dot is smaller than the small rectangle, and I'm gonna say that one should be false. I will assert false, the actual is smaller than. Okay. So we'll say bigger should be bigger, yes. Bigger should not be smaller. Right, we're going to check them both. I don't know, feeling a little bad, but that's okay. Testing both at once, but I think life is easier that way for us right now. Then we're going to test smaller. So we're going to flip these around. We're going to say, hey, is the smaller rectangle bigger than the large rectangle? That should be false. Right? But then smaller, is the smaller rectangle smaller than the large rectangle? Should be true. So we're going to flip these. We'll say false, it's not bigger, and true, it is bigger. The idea here is I want to get both cases. Right? I want to be able to check the is smaller actually smaller, or is larger not. It's because I want to get the true and I want to get the false result back out. That's the idea here with these. So let's give them a try. Okay, they passed. Cool. So we're feeling good about that. Now we can also test, right, our is same size. And now I'm feeling a little bad here because I remember back to math class, and I think there's another case in which our rectangles could be the same size. So we're saying, does the length equal the length and the width equal the width? What's the other case in which rectangles could be the same size, where this would not be true, but we'd still have the same size rectangles? You folks remember? It's all just a naming issue, right? So I'm going to say that, or my length equals the other width, and my width equals the other length. So we just named them badly, right? That's okay, right? If my length is the same as their width, and my width is the same as their length, we're still really the same rectangle, right? Length and width are just names for it. I think we're the same size at that point, whether or not we're long or tall, right? Whichever way you want to imagine length and width. I think saying those are the same size is mathematically correct. What do you think? So we should test both cases here then. Is same size. So if I make two rectangles that are both 2 by 4, then we're going to get an is same size, is same size, is same size, and we'll assert that it's true that they're the same size. Right, and then I want to do this with length same as other width or something, right? Whatever that is here. So if I flip these values, if I'm a 2 by 4 or a 4 by 2, I should still be the same size, right? Because that's just a transposition, right? We've just taken a rectangle and flipped it on its side, essentially. Same thing here. Uh-oh. What did I do wrong? Main method not found. Did I break it? I thought I hit run. Huh. Did I get too many curly braces? No? Okay, there it goes. I think I hit run instead of test. There we go. Is same size. Oh, and same size as length, same as other width. Okay, cool. I like that. Did this make it feel any better or worse now to look at some of these comparisons and do a little bit more with our rectangle? Because I know it was a little bit fuzzy. Definitely we needed some practice on it. Excuse me. And that Perrier, that's got some bubbles. Which I didn't realize, I mean, up until relatively recently, that it's naturally carbonated. It's not artificially carbonated. So like somehow this spring there in France has carbonated water. I think that's really neat. I don't know how that works. Personally, you know, like the Soda Stream where you can like you just shoot the compressed carbon dioxide into your water to carbonate it. This is naturally carbonated. Not that it makes any difference, but just like that it could naturally occur that you'd have bubbling water coming out of a spring. Just kind of boggles my mind. Like we get some cool stuff going on in the world. All right, folks, how we feeling? How's project 3, by the way? Let me ask you here. Let's do a little Twitch poll. Project 3. Done. It's there. Barely started. So yeah, give that question a look here. Tell me about how Project 3 is feeling there in the Twitch chat poll. And let me know if you're already done, almost there, barely started, or Project 3? Because that one is definitely coming up due by Monday 10 a.m. So we're not going to have, oh no, we're not going to have a lot of time to work on that one, right? We've got today, I've got some office hours today. Go to study group, talk about it. Please go to study group and chat with each other. I would strongly encourage you guys to chat. Don't share code, right? Sharing code is a violation of our academic integrity policy, but chat about it. Like, this is what I need to do here. This is, these are the steps I'm going to take. Perfectly fine. Go through that. Okay, a lot of barely, I appreciate your honesty there, folks. I'm going to admit it hurts a little, as we've had this project for quite a while now. And now I'm wondering if giving such a long lead time means we just put it off and put it off and I'll be honest, I do that too. If someone sends me an email and says, hey, I need this thing by Friday, I'm not starting on it till Thursday or Friday. Definitely not starting on it on Monday, but okay. Let's call it a day then. Take this extra, half an hour, a little bit of time, get moving on it, and then go to study group and chat about project 3 in study group, please. Okay? Does that sound like a good plan? I think that's a good plan. All right. I don't have anything else that we've gotten through chapter 6 pretty well. Actually, that's pretty good. And let me go see if there's someone else around on Twitch for us to talk to. Let's see. I don't know if we can raid her channel or not. We'll see. I want to go learn some chemistry. Nope, we cannot. So she must have had raids turned off. Bummer. Let's watch someone make some art here. That's fun. There we go. This is good stuff. Doing pottery. We'll head over that way. Say hi. Work on the project. Go to study group. And I'll catch you guys for office hours today or Thursday. If not, I'll see you Monday. We'll talk about the solution. Take care.